Oh, I have to remirror. Okay. Okay, I think we are ready to go. It is recording and I'm mirroring the screen. So a couple of weeks ago, I guess a month or so ago, I presented on what I was doing with what I was calling vibe coding, but what JP said is really just software engineering in the modern sense. And I think he's right because if you remember back, I had like 18 pages of specs that I told it to do. So I wasn't really making it up on the fly as I went through, but I had specifications of what I wanted to have it do. And I'm actually about to do it again this afternoon, and I have 48 pages of specifications for this new one. So we'll see how it builds. But will be presented in the spring project. But one of the things that came up in that conversation was, so in that conversation, I ran it on Claude Code, OpenAI Codex, and on Gemini CLI. And then each of them created a code base off of the exact same instructions. And then I wanted to evaluate which code base should I use as my code base and which one should I just get rid of. And so I looked at them and I thought about things that I liked how they did it, like the file structures that would have been the way I would have done it and stuff like that. And then I had a colleague at Carnegie Mellon who's a PhD student there do the same thing. I said, just look at these and see which one you think we should use as our starting base. And we both ended up saying Claude Code was the one we liked more, but we really couldn't say why. Which got me thinking about, well, how do you audit what these give you? So it turns out a whole bunch of code. So this is different from like giving ChatGPT a snippet of code and saying, this isn't running, tell me what to fix, and it fixes a line. But I was thinking more in terms like you tell Claude Code, write me a new feature for something and put it into this GitHub repo. And then I have to review it and decide, do I merge it in with what I'm doing? I have to decide whether I like it or not and how it did it. So
You ask it to do a PR.
Yes, you ask it to do a PR and then you have to evaluate it. So I've been thinking about this and I thought this would be a good topic for discussion. And so, of course, I use ChatGPT to help me get my ideas straight. So I wrote a whole bunch of things that people had given me. Like I talked to a colleague at Michigan and I asked what he does because he is an open source manager for a LMS project that's been going for like 15 years. And I said, how do you ever manage all the pull requests and understand? Because they're using Claude Code to write all the new updates for it too. They're not writing that much of the code themselves anymore. So it took a lot of my ideas, added some good ideas, and synthesized it most importantly. And so that's what I want to kind of go over and share and discuss with everyone. So let me go ahead and share my screen on Zoom. First, let me copy the link so I can put it in for everyone. Okay, so I'll put the link into it in the chat, and then I'll share my screen. And this is, I had it created kind of as a checklist just for ease of discussion. Okay, move some stuff. Way too many screens going on here. Okay, make whole thing bigger. So as you can see at the beginning, the first in the TLDR is be sure to read your code, which I think is kind of an obvious one, hopefully, but maybe not. Maybe everyone doesn't actually read it. And then kind of start small, run small tests to make sure that it's actually working. Then do things like run, if you didn't build them into like your pre-commits, run black to help make the code cleaner, run bandit, which is for those who do Python. It checks for security flaws within your code. Also then confirm the results it's giving you. So the context I was thinking of this is for developing research software. So, which leads you to some challenges around like how do you confirm the results? Because it's not just is it outputting something, but it's outputting something that is accurate. And is it getting to that accurate in the right way? Because it could look very accurate, but once you move to edge cases, it gets wrong because it's using a wrong multiplier somewhere or something like that. Whereas like if you're just developing an app that someone's going to use, you may not care about how it gets the results as much as long as it gets the results. Because your edge cases are less problematic to you typically. Yeah, so the advice it gives is to, of course, read all of the code. And it says line by line, but that gets awfully problematic when you're talking about really large code sets. So here I can actually bring up my, let me go to the Git repo for this and just show you. So let me go. Where? So this was, yeah, so this is the code that it produced. And if you look like in the scripts, why is it not opening? There we go. So there are lots of files with lots of things going on, and some of these get really long. Like this is 941 lines of code if you count blank spaces. But I do think,
let's read through it now.
Yeah, let's read through it now. It's a lot of fun. So I do think, though, that as we use these tools more, we're going to have to come up with better strategies of how do we actually know what's happening in our code, even if we didn't write our code, but we have to understand what is happening. And one of the ways that I found useful was I read the import statement at the beginning to make sure I understand what it is using at least and where it's pulling data from for each of the files. Even if I don't read all the things below, just knowing how it's the logic it's using to connect my files together was really helpful. And then I read core functions because those were ones I knew I'd want to edit. Yep.
Sorry to interrupt. Have you
Oh, no, of
experimented
course.
with asking Claude to write nice comments?
It does it naturally.
Oh, okay.
Like you don't have to ask it even. It will comment its code really well. What I haven't done yet is ask Claude to do code reviews for itself. But I did tell it in my instructions to do PyTest and to do test-driven development so that it would write the test first, then write code, and then test the code. But what I didn't go back and do, which I should do if I'm going to use it for actual research, is to look at what are the test cases it's using to test the code. Like, is it just using real easy tests that it knows it will pass? And then it can write sloppy code to pass those tests. And I have read that people say it does that a lot. Like if you...
I do see it do it so many times. It's just so frustrating. I'm like, this is really hard. Can you please try to solve that problem? And it's tell exactly what to do. And it's like, that's just really hard. So we're just going to skip this test. You just comment it out, or it'll put like a statement that's like, if this is the case, which is the hard case, then just don't do this thing. And it's like, and then it's like, I solved it. Congratulations. Like, it's like so confident that it's happening. Like, you did not solve my problem. Like, I'll call it out. Like, you literally just skipped the test. It's like, oh, you're totally right. Let me do it again. And then it does nothing. It does nothing. It doesn't do anything. It keeps it, so it's really stupid. You really do have to read your.
Ryan, I'm curious in your prompt, do you require some good coding practices like modularize your code, don't have a single script that's too long, that kind of thing?
Yeah, so I can actually bring up,
Oh, boy.
Prompt.
This is the
Yeah.
8-page prompt.
well, no, I have a longer one, don't worry. I just have to figure out which. Yeah, it's not in there. That's HPC. I have a lot of windows going. Yeah, that's that one. Because I just finished working on one for this. Actually, I can do this. It is recent. So what I've been doing is, here is the design specification document for the new one. And I'll blow that up. So it has goals, purpose, and then it talks about some of the structures. And then I think it is down in section 9 where I tell it like what type of code. I guess I could just search for. Yeah, so in a file I call agentsmd, which if you're using Claude code, it looks for first to find instructions for how to write code, and it will refer back to it. So here's where I tell it like to use test-driven development processes. I tell it not to modify tests unless there's an actual error found. I tell it to use black for formatting, rough for linting, bandit for security as pre-commits. Yeah, I tell it to do a lot of things that I think are just good coding practice. Some of that I've copied from others. A lot of this process is also, so a while back on Slack, I posted that someone's writing a textbook on how to develop software for research purposes, which is this coding and science book. And a couple weeks ago, he had a section on test-driven development and AI-assisted coding. And he really broke out his strategies of how to get AI assistant coding to structure. And one of the things he talked about in that, so this is called Coding and Science Book, and it's a Substack, but he's writing a book as blog posts that then he'll bundle together and make public at some point. But he's writing it kind of week by week. So every week or so you get a new chapter, short chapter. But one of the things he said to do is to create these files. So in addition to the agent.md file, which gives all the instructions, you give it a separate file to do its planning in, and you tell it to do all of its planning in a planning.md. So it has a storage area of what it's planning. And then you tell it to do a task list and then to have a scratch pad, and you tell it what to put into those. And then a problems to be determined, where it kind of puts things into a parking lot, kind of like when you're in a meeting, you put some things off to a parking lot, and you give it a file to put things off into the parking lot so you can refer to it later. And he talks about why this structure works really well. And it helps Claude manage itself better when Claude is writing code for you, especially for big pieces of code like this. Yeah, so some of the other things, it said, like, look for any place where there's hard-coded paths. You probably want to take those out. Of course, you want to look for secrets and credentials that might have gotten put in there somehow or didn't make it into the git ignore. Now, if you're using Bandit, it will catch all of those easily where you accidentally put your API code in, as well as a lot of other things. But if you're not using that, then you want to watch out. And typically, so like with the newest one that I'm building, I went into GitHub, I created the .env file and put my API codes in there and made sure it was in git ignore, rather than trying to have Claude Code do that, because I would worry if anything went wrong. I wanted to make sure those were done right. The next thing then to kind of checklist if you're going to look at your code that was developed is to look for formatting. Again, I was thinking in terms of Python in this, so we use PEP 8 standards for formatting, and you can either use Black or AutoPEP for that. I assume there's something parallel for R or Ruby or whatever you're using, whatever the standard formatting pieces are. Yeah, and anything that you want, like function names, you want to make sure that it created real functions and that it really does that. This is something that I've noticed too. It will make up like the faux will come up, and you'll wonder why like a function in the middle of all the other good functions is all of a sudden called faux. And it's like, well, wait a second. And then you kind of have to do some trace backs to figure out what did it really mean? This should have been, and then do some renaming, which can be annoying. Or you can try to tell it to fix it. But again, it doesn't always like to fix the things that it didn't do right, as JP pointed out. It probably had some illogical reason for doing it, and it thinks that that's the right thing to do. Looking for modularity. This is something that I thought Gemini did pretty poorly on, was the modularity of the code. Like its functions were really big. Like you would open a file and it would have like one big function in it a lot of times, and that wasn't going to be useful. All in all, I thought Claude Code did a good job with that. Yeah, and the reusability of parts, it wasn't my concern with the one I did. But I can imagine like with your project, JP, reusability is a fairly big issue. So you would want to go through and make sure that it developed it in the right way. And again, you can put that into the instructions, like any of this that is important to you, you can say in the instruction file, be sure to build it in a modular design. And it helps, but it will forget at times, I find too. Like it'll do some of it really well, and then all of a sudden it seems like it will start to forget some of the things that you told it earlier. And maybe that's because I give really long instruction files. Maybe I should have it build one piece at a time. But we'll find out this afternoon if the new one works or not when it's done. Yeah, and then the testing, and I think this was like one of the biggest takeaways for me was, again, even if I ask it to do the test-driven design process, it tends to test itself on the easiest ways possible to make sure that it is successful instead of testing on the harder ways possible. And so you're probably going to have to go in and do your own testing with your own. You're just going to have to add a lot more cases to their test. So if you're using PyTest, you just want to go into the file and add a bunch of different things for it to test, so that it, yeah, has a harder time with it. So as the checklist says, think about like giving empty inputs or having times like when it has, if you want it to have like data that should have been imputed but wasn't, and is that going to throw an error or not? Tests extreme values, things really close to zero, negative values, or really large values. And then look closely at the results, because that's where you'll see if it's not doing it well. Especially for scientific computing, again, just getting a result doesn't, even if it's the right answer, it could have been done through the wrong process. And then when you get other data, it's gonna really throw you off. So looking for the error messages. The good thing is if you're logging all your errors, you can ask Cloud Code to go through the error logs and to fix the problems that it finds, which is really helpful. Again, if you're using Cloud Code or one of these CLI tools, it continues to have access to all the files that it created and tested and ran. So you can just tell it, like, look in these 3 log files, find any problems that are happening and fix those problems, which is just a lot easier than having to open those files, copy and paste it into like ChatGPT and say, why am I getting these errors? And then where would you fix it? And then it doesn't know your code base. So it says like, do you have this type of file? That's where it could be somewhere like that. But that's still really useful. And I still do that a lot too. But if you can do it in Claude Code, then, or if you're using Codex, I probably wouldn't use Gemini at this point, based on my experience, at least. Yeah, I guess, do we want to talk about any of these? I mean, I'm happy to keep going through. I think there were 10 categories in all that we kind of narrowed down to. Or do people want to talk about some of their experiences? Have people been playing with some of these coding tools where it just writes a whole bunch of code for you? I know JP has.
Run right now, it's not working. That's basic. I mean, I use Claude Code for everything, and most of it is partially because my use case, doing package development or something. And I use Positron more now as my main IDE because it's a fork of VS Code, so it works really nicely with Claude Code. Having a really good Claude.md file is really important. It's one thing I found, like putting that in the root directory and telling it all kinds of stuff about what your project is and what you're trying to do. It makes a big difference. I give it like links to documentation sites of things. I'll say, we use these packages and here's the link to every single one. So you can go read up on those, and just giving it that level of, this is what we're actually attempting to do here in the big picture. It makes, otherwise it's just shooting code in the dark. It really doesn't know what you're trying to achieve. That's been a big like source of improvement, just giving it focus.
Is that something that anybody contributing to your project would use to?
Yeah, I usually have it in the repo. So like if you fork the repo, you have my Claude file as well. And often because we are collaborating with other people, so I tend them to use the same one if they use Claude Code. But it still does make up stuff. Like if it's really hard, it doesn't know what to do, it will just make things up that it's totally not it. So you have to be really disciplined about going through and reading your stuff. And I tend to use it on very small scale, highly focused instructions. So I'll write like a whole page of instructions. This very specific task, and then I hand that to it and I'll watch it go. And then I look at the changes on GitHub to see like, okay, what did it actually change? And that's what I actually, because the hardest thing is sometimes you can't see what it changed if you have a really big code base. So I look at the GitHub changes on my GitHub desktop. Okay, it made the improvement that I wanted or it didn't or something. I don't usually tell it to do a really big task and then just like YOLO it. Like, that's not gonna lead to a good outcome. But if you do it right, if you do it really well in that kind of discrete steps, it will save you tons of time. Like it wrote a lot of stuff this morning. I was building a Shiny app on the train, and it converted a lot of what I had into a Shiny app. I was like, perfect, that's what I wanted. But now I'm trying to work on deploying it, and it doesn't understand that. So I'm having to kind of do it all myself. So
Yeah, I watched a good podcast video type thing the other day that was the two lead developers of Claude Code at Anthropic. And they were talking about how they use Claude Code like as superpower users.
Yeah.
And it got a little crazy. He's like, yeah, I will be like at a stoplight and I'll just send like at Claude, do this before I get to the office and have it spin up a bunch of agents to create code for me before I get there. And I'm like, yeah, I'm not that far advanced. But I'll post it into Slack so people can watch it. But it was really interesting kind of to hear, like, I'm way down here, they're way up there. Somewhere in the middle is probably where I want to be, like just gaining a lot more efficiencies by using it. Like they create their own slash commands. So
Yeah.
slash commands are like, they're kind of like small prompts that you've built up already. Like, but they do one for like PR reviews. And then it spins out like 5 agents to review for different things in a PR request. And then one of the agents summarizes for them as the PR reviewers what they should look at in the PR request so that they don't have to look at everything. But it kind of says like, these lines are ones related to security features. You should be sure to read those. This are issues. And they can just quickly go through. And once they build them, then they just have them for all their uses.
Yeah.
Which I thought was pretty interesting.
I use it for these background tasks, you know, where I am multitasking and working on something else. And I'll just be sort of monitoring it. If that's what I'm doing. Giving it the task. It goes, I know it's probably gonna be done in like 5 seconds, but then I'll actually just go work on something else for like 25 minutes. Then I'll come back. I know it was already done, but I'm like, I don't know how long it's gonna take. So I'm just gonna do this thing. When I come back at it, then I'm just reviewing changes as if I had, you know, an employee writing that code for me. And so I do things in steps. I'll have like a plan written down, like I want to do this, and this. And I'll just send it off one at a time while I work on something else. Come back to it and check it, see if it's on task, do it again. So we make a lot of improvements that way quickly. I mean, we just like the one that I mentioned on GitHub about like that shorthand syntax for survey down. I was like, we're thinking about changing the syntax to be shorter hand. How do we do that? We just had it build that for us over the weekend. It's a pretty small change. Now it's already on prem. Like it's already pushed. It's all there now. So that was like I was working on something completely different the whole time that I was working on that. And I just tested. I knew what I wanted it to do, and I just did lots of testing on it, but I didn't have to write most of that code. So it is very nice for like that kind of stuff, like doing package development. It's awesome. But it will betray you. So don't ever trust it. Yeah.
I had a question.
Mhm.
How to say this? How do you know, is there a way to know what assumptions Claude is making with respect to like coding best practices? Like maybe you don't have to put in all this stuff because it's following some basics, or do you just need to cover CYA so that you have it do it what you want?
I don't know. And again, I'm not a professional software engineer, so, but I think that like, especially there's like what do general people do? And then like most companies have like their own specification manuals and they want all their code done certain ways. And it's probably been trained on a lot of that too. So I'm not sure if it necessarily knows what are quote unquote best practices because it's context dependent.
Right.
Like, I mean, there is some like PEP 8 is kind of accepted, but a lot of like a company will have its own version of PEP 8 that they want for their coding for some reasons that
Right.
I don't know. But
it sounds like it takes shortcuts a lot. So if you're saying, if you want something that's like a really accessible user interface, then you would need to nudge it to focus on that.
yeah, probably what it would build would
Wouldn't do that
not,
by default.
or not what you're in mind of what is a usable interface, because
Well, I mean like accessibility issues.
accessibility, yeah, you would. It probably wouldn't build it naturally.
Which is
Yeah.
disappointing, but maybe understandable. Because it's trying to just do the shortest, fastest way.
Yeah. Yeah.
It's also terribly bad at when efficiency matters, like computational efficiency matters. It cares nothing about efficiency. It will write the dumbest for loop. That's so like if you need to do like a sum product thing, and you can just use a matrix math to take rows and columns and do that really efficiently. It would just write a for loop and loop across every element and multiply them all separately and then add them up. It would do it in the most like how you would explain the steps to a toddler. Like, well, first we take this cell and then we add it together and then we do this. And I'm like, okay, that works. It will solve the problem. And it takes 10 minutes to run. And if you just use it as a matrix math, it will take 0.1 second. And it just has no conception. It seems to have no conception of like efficiency of how you can solve problems differently. Even if I really force it, I will tell it to use matrix math to solve these problems, and it's like, that's a great idea, so here's a for loop, and it just doesn't care. It's just like, whatever, I'm gonna loop across these cells in the data, and really doesn't understand that you can solve things different ways. So it rarely matters these days that you have to do that kind of thing, but sometimes it matters a lot. Sometimes you're doing these really difficult tasks, and like we have a problem right now where we're looping across data on every single census tract in the country. And there's like 80,000 census tracts, and each one, so if you can reduce your computational time for each census tract by like 50%, you've gone from like days to hours kind of thing. And every time I've tried to have it do it, I just can't work with it on that particular problem at all. Like every task it tries to do is the dumbest way to do it, the slowest way, using the slowest package, and I just have to like say no. I'm just gonna have to solve this myself with my brain, I guess. And so efficiency is the single biggest flaw I've found, where it writes horrible code if efficiency matters. If you just need to get the thing done, then fine. It'll write something that will work. But
Ryan, have you tried doing like with the research that you're doing and things like the NIST AI risk management framework? Have you tried feeding something like big like that into it to see if that would help it or confuse it? Or
I haven't tried it. I'd have to think about how to set up an experiment so that you would know like how it did it differently with and without it.
that'd be interesting.
Yeah. And which type of task it would show up best in. Because again, if it has 80 files, finding it could be really hard.
Yeah.
Other than, I guess, use git change, and then you could maybe see it, like what the differences are. Or just feed it both sets then and say, what are the differences and why is one better? Because it will read all the code and find it quicker than you will.
Cool. Very interesting.
Yeah, so a few more things out of the checklist that I thought were interesting. Especially around, and I think this kind of goes off of what JP was saying too. If your math gets complex, be sure to look at those sections a lot. So if you have part of your pipeline that does have complex mathematics going on in it, be sure to look at those parts, because it may not have done quite what you think it was doing to get your result. And it may look fine at the end, but not be fine. Also looking at your requirements, that text file, to see what are the different dependencies that are being used. It kind of depends, I guess, on how you like to program too. Python people tend to like to use a lot of packages. I know that in other communities, using fewer packages is considered desirable. But in the Python community, lots of packages.
People love dependency help for some reason.
Yeah, it is true.
Fine, I'll live in this hell with you. That one, the other thing that people trying to think about, but talking about this is not just efficiency or math. Like if you have you should have a clear way of what you want to solve. Like you should have the problem solved in your head before you start this stuff, I think. Otherwise you're just asking for problems. Like if efficiency matters, right? If you know, even if you tell it to do matrix math and it doesn't do it anyway, at least you know what you wanted it to do. And so my asks of Claude Code are like super specific on what I'm asking it to do, and it still will sometimes not do what I've asked. But if you don't know what you want, if you're just like solve this hard math problem, that's terrible ideas. Like you're just asking for so many headaches. It will not understand. It will do something, but it will unlikely be what you wanted. And I think this is where a lot of students get in trouble because they haven't solved a lot of complex hard problems where math actually matters, maybe, or they're still learning that math, and they're still using these tools to try to get it to work, but they're not telling it exactly how you want it to be solved. And so it's just picking its best guess, which is usually a really slow or not so great way to solve it. And a lot of times it'll look like it solved it. Also, there's like just physical limits to certain things. Like we had a weird case where we were building a Shiny app where it was something about market shares of companies in a market. And so depending on how many companies you have, you can get this summary metric, but there's certain fundamental things where like you have to have at least a minimum number of companies for this to work. And if you just set it to 2, it would just break. It wouldn't understand that it would break, and so it would keep trying to just make up numbers because it didn't know that like you had to have at least three companies for competition. Like 2 is not enough, and there's just like mathematical definitions why 2 is not enough. And as soon as we told it that, we were like, you do realize that you have to have at least 3. And it was like, oh, you're right, n must be greater than 3, and then it just worked. And it was like this stupidly long, frustrating thing of like, why isn't this working? We were all thinking it must be understanding this, but it didn't understand that principle. And so just make n be greater than 3. And it was like, okay, solved. So yeah, you can spend as much time debugging the thing if you didn't give it enough very, very specific things about the mathematical problem you're solving. Math is where it just loses its mind because it doesn't understand math.
I'm afraid the message that I'm receiving right now from this is that you have to read the code, you have to understand the code, and that vibe coding
You still have
is
to do
for
software
people who know how to code.
Yes.
Yes, it's for experts.
Yes. Yes, I mean, it really is. Like,
You have to understand the problem well enough also. Like, if you don't understand the problem well, again, it will give you results and you won't know that it's wrong when it is wrong. Because,
It's taking the fun out of vibe coding.
yeah.
oh, it's still a ton of
You
fun.
have to be able to read the code.
But reading code is a lot easier than writing code.
I mean, you don't
Like-
have to know the language though. That's what's different. Like you can you have to read the code, but you don't have to understand the language. It sounds weird, but I like an example of me is like when I'm working with Cordo, we'll use these Lua filters, which is Lua is its own language. I don't really know how Lua works. It's kind of like looking at JavaScript code. I'm like, I don't really know JavaScript, but I can look at a function and kind of trace through it and be like, all right, that looks like it's probably an if statement, and this is what's happening. I can get the logic, the gist of the logic. And so I can get a quick sense of probably my guess of what's happening. And if there's something really crazy, some long one-liner, then I'm like, all right, I don't know what that is. And then I might actually ask it, explain that one line to me. And so it wrote its whole Lua filter for me, and I don't know Lua. And I still read the Lua filter, and I parsed through. I was like, okay, it's looking for this, then it's splitting up on this, and then so I completely understood what was happening. I don't know Lua, so I've never written that myself. And that's where like that's like the closest to maybe like vibe coding I experience, because I really don't know what's actually happening.
Yeah.
But I have a 90% sense of like, I think I know what's going on here. So
Yeah, my vibe coding, like if this is software engineering, I'm good with that. I vibe code though, like I run servers with websites on them, and I don't understand a lot of how websites, understanding how my server runs with Nginx on it, and some use GUnicorn and some use something called UWSGI for the Django sites. I just throw all those errors into ChatGPT. I'm like, how do I fix this?
Yeah.
And it's because I don't want to know. It's like, I don't ever plan, other than running these 10 websites that I do for fun. That's not my career path, is to understand how web servers work and all the different protocols and certificates and back and forth.
So when you say read and understand the code, you really mean skim it and make sure that it's not doing anything that's like insecure or like an error, you know, in the
Yeah,
logic.
like watch where the variables are being passed and then see like, okay, so it's sending all this to this other function. Then go look at that function and says, what is this function doing with that type of,
Mhm.
at least that's how I do it. I
Yeah.
don't. But yeah, you kind of have to understand the logic though. So if you have no coding experience, it's really hard because your brain just doesn't naturally work like that, I think, for most people. But once you've coded for a while, your brain kind of naturally works like that. Like you do function tracing and you can just go, oh, here to there, to there, to there. Okay, that's why I got this.
Yeah, and a lot of the points of confusion are like some of the most fundamental things, like, are you in the right working directory? Like, don't know how do people really understand that concept well? Really, it's shocking how 50% of the time, at least in most of my classes, that's the problem.
Right.
We're not in the right directory, and that's why none of this is working. Everything looks great, you know, I'm reading your code, looks wonderful, but it's just pointing the wrong way, or it's file handling of like, we are saving this data here, we're passing it over there, that function, and you thought you were passing this one, but actually you were passing this test data, not the real data. And so everything looks right, but there's just this weird tiny little miss there. And sometimes it'll catch it, but a lot of times it won't, because Claude is like, it's right. What are you talking about? The code's good. I checked it already. And it thinks you're in the right directory, but you don't know that, you know. So God, some of that stuff, that'll drive you crazy. But yeah, my reviews are very skim. This goes back to last week's, which was about the GitHub desktop. Why I like GitHub desktop so much. I can see the changes right there, and I can have Claude. I have 3 or 4 sessions of Claude code going at once, maybe. I just go to the changes and I'm like, okay, that's what was changed. So I can know, are you making some crazy decision very quickly? Especially if it's in the language I know. If it's something I don't really know, I might spend a little more time with it, or at least do some testing before I commit those changes. But yeah, if you don't know how to code trace at all, like if you just don't know any language, that'll be just total black box. You don't know what's going on. That's scary.
But people are doing it. And it might be the app that's running your house soon. It's vibe coded. Okay, so I put the link into the chat and I'll put it into Slack if anyone wants this. It might be useful. Feel free to take it, steal it, borrow, revise, improve, whatever is necessary, whatever is useful for you.
Awesome. Thank you so much.
Oh, okay. Yep, I'll put it in
I feel
Slack.
like I should just come in. One of our sessions should be like, I'm gonna do this task, like convert my Shiny app from art